Hello again. This is our second attempt at making our pre-calculus video for today on Tuesday, November 29th. We are heading towards being able to solve some basic trigonometric equations, and here's an example. We will eventually be able to find all values theta such that sine applied to that value theta will equal exactly positive 1/2. Okay. Now you might recall from yesterday's discussion that we have to be careful when solving equations where one of the components is not 1-to-1. So I had an example yesterday of the graph y equals x squared. If there's no restriction on the function, then it would be a parabola concave up with vertex at 0, 0, and it would not pass the horizontal line test. So for my first example yesterday, I restricted x to positive values or 0, which gave us this bold-faced red part of the curve. Now that half parabola will pass the horizontal line test. That'll pass the horizontal line test in red. And then if we reflect the graph of the bold-faced line, we will end up with the graph where the axes, input and output axes, are switched, and we would get the positive square root of y equals x this way. Now had I made a different restriction, let me make sure my camera's still going. It sure looks like it. If I had picked the other branch of x squared and had the restriction that x was not positive, but x was less than 0 or equal to 0, then its inverse function would have a graph here in the dotted blue. And so if the boldface had been x squared restricted to non-positives, then we would have chosen the bottom branch for the inverse relation. And I mentioned yesterday in class that in calculus and beyond, when we're talking about pairs of inverses, they won't make the distinction between input and output, x and y. So just heads up, if you look in calculus books, they'll talk about pairs of functions like x squared restricted to non-negatives, and then the positive branch of square root of x. And then they might have talked about a separate pair where g would have the same rule but a different domain, and therefore g inverse would be the opposite branch of the square root function. Okay, so that's setting up for what's to come as we solve trig functions. I'm going to pause there and maybe cut the next video. See you in just a minute. This is the end of part 1.